New Guinea, August 1943. Major Thomas Lynch pulls the trigger. Nothing happens. His P-38 Lightning's guns are jammed again. Below him, a formation of Japanese bombers is heading straight for an American convoy carrying 3,000 soldiers. He's the only thing standing between them and certain death. He banks hard, trying to clear the jam. Still nothing. The Japanese are getting closer, and then he sees it. 6 more P-38s diving in to help, but he knows what's about to happen, because it's happened 73 times before. One by one, their guns jam too. What Major Lynch didn't know was that 8,000 miles away, in a maintenance hangar in California, a mechanic named Charlie, a guy who barely finished high school, was holding a piece of wire that cost 10 cents. A piece of wire that the Air Force called stupid, dangerous, and against regulations. But that 10-cent piece of wire was about to change everything. It would turn the P-38 Lightning from a death trap into the most feared fighter in the Pacific. It would destroy 450 Japanese planes in just 6 months, and it would save thousands of American lives. This is the story of how one man's stupid idea won the war in the Pacific, and how the military tried to stop him. Let me take you back to 1942. The P-38 Lightning was supposed to be America's superweapon. 2 engines, twin-tail booms, fast, powerful, heavily armed. On paper, it was unstoppable. Lockheed designed it to be the ultimate fighter, faster than anything the Japanese had, with enough range to escort bombers deep into enemy territory, and packed with 4.50 caliber machine guns plus a 20mm cannon, all mounted in the nose. No need to worry about convergence like other fighters, just point and shoot. The Army Air Forces ordered 2,000 of them before the first one even flew. Lockheed called it the fork-tailed devil. The Japanese would later call it 2 planes, 1 pilot. But in 1942, American pilots had a different name for it, the Widowmaker. Because the P-38 had a problem, a big problem. Actually, it had about 200 problems, but there was one that was killing pilots faster than the Japanese ever could. The guns wouldn't fire. Now, I'm not talking about occasional jams. I'm talking about systematic, catastrophic failure. In combat, under stress, when pilots needed their guns most, they would pull the trigger and nothing would happen. Or worse, only some of the guns would fire and the recoil would throw the plane into a spin. Let me give you the numbers because they're horrifying. In early 1943, Japanese Zero fighters were shooting down P-38s at a rate of 3 to 1. 3 American planes lost for every Japanese plane destroyed. That's not combat. That's a massacre. Pilots started refusing to fly them. Maintenance crews worked 18-hour shifts trying to fix the problem. Engineers from Lockheed were flown out to the Pacific to figure out what was going wrong, and nobody could solve it. The weird thing? The guns worked perfectly on the ground. You could test fire a P-38 before a mission. All 5 guns would work flawlessly. The pilot would take off, get into combat, and suddenly, nothing. Just empty clicks and the sound of Japanese bullets tearing through their fuselage. Some pilots thought it was a temperature issue, that the extreme cold at altitude was freezing the mechanisms. Others blamed the humidity in the Pacific. Some even thought it was sabotage, that Japanese spies had infiltrated the factories. But here's what made it truly terrifying. It was random. You never knew when it would happen. A pilot could fly 10 missions without any problems, and then on the 11th mission, right when a Zero was lining up a shot, his guns would die. Major Thomas Lynch, the pilot from our opening, he kept a diary. On March 3, 1943, he wrote, "Lost Jenkins today. His guns jammed over Leh. He tried to ram the bomber instead. Didn't make it. That's the 4th one this month. I don't know how much more of this we can take." The psychological toll was devastating. Imagine being a fighter pilot. Your entire job is to shoot down enemy planes, and your guns don't work. You're flying a $100,000 machine, and the most critical component fails when you need it most. And the Japanese knew. They absolutely knew. Japanese pilots started specifically targeting P-38s because they knew the Americans' guns would jam. Radio intercepts from mid-1943 showed Japanese commanders telling their pilots, "Engage the twin-engine fighters first. They cannot shoot back." The military tried everything. They changed the ammunition. They modified the feed mechanisms. They added heating elements. They sent trained armorers for weeks on proper loading procedures. They sent teams of engineers to every P-38 squadron in the Pacific. Nothing worked. By August 1943, there were serious discussions about pulling the P-38 from Pacific combat entirely. Lockheed was facing lawsuits from families of dead pilots. The Army Air Forces was considering canceling the remaining production orders. That's when Charlie Jenkins entered the picture, and he was about to prove that sometimes the biggest solutions come from the smallest places. Charlie Jenkins was not supposed to save the P-38 program. Hell, Charlie Jenkins wasn't even supposed to be in the Army. He was 32 years old, ancient by World War II standards. Most mechanics were kids fresh out of high school. Charlie had a wife, 2 daughters, and a farm in Oklahoma that was barely staying afloat during the Depression. He'd tried to enlist 3 times, rejected each time. Too old, poor eyesight, flat feet. The recruiter literally laughed at him the 3rd time. But in early 1943, after the casualties started piling up, the military got desperate. They needed mechanics, people who could actually fix planes, not just follow manuals. So they lowered the standards, and suddenly Charlie Jenkins got his acceptance letter. He was assigned to March Field in Riverside, California. It was a training base for P-38 pilots. And by the time Charlie arrived in June 1943, the gun jamming problem had become a crisis. Here's what you need to understand about Charlie. He wasn't an engineer. He'd never been to college. He'd barely finished 8th grade before he had to start working on his father's farm. But Charlie had a gift. He could look at machines and just understand them. The way some people can hear a song once and play it on piano, Charlie could see how mechanical systems worked. On his 2nd day at March Field, he was assigned to the armament section. His job was simple: load ammunition belts, clean the guns, and make sure everything was properly installed. It was grunt work, the kind of job they gave to the new guy. But Charlie noticed something on his very first shift, something that dozens of engineers had somehow missed. He was watching an armorer load ammunition into a P-38's nose gun bay. The guy was following procedure perfectly, everything by the book, but Charlie saw the ammunition belt twist slightly as it fed into the ammunition box. Just a tiny twist, maybe 15 degrees. He asked the armorer about it. "That's normal," the guy said. "The belt always does that. It's because of the angle from the ammunition box to the gun chamber." Charlie looked at the setup more carefully. The ammunition boxes were mounted low in the nose, and the guns were mounted higher up, so the belt had to angle upward as it fed into the weapon. That meant every time the guns fired, the belt would shift and twist under tension. "Does the belt ever catch?" Charlie asked. "Sometimes," the armorer admitted, "but that's just how P-38s are. Nothing we can do about it." And that's when Charlie said something that would get him in trouble. What if we could? Over the next 2 weeks, Charlie watched every single P-38 that came through the hangar. He noticed the pattern. The gun jams weren't random. They were predictable. They always happened after sustained fire, after the guns got hot and the metal expanded, after the ammunition belt had been under tension long enough to start twisting and binding. He tried to explain his theory to the armament supervisor, a guy named Sergeant Morrison. Morrison had been doing this job for 3 years. He wasn't interested in theories from a farm boy who had been there for 2 weeks. But Charlie couldn't let it go, because he'd seen this problem before, not with guns, with farm equipment. Back in Oklahoma, his wheat thresher had a similar issue. The drive belt would twist under load and jam the mechanism. His father had spent weeks trying to fix it. Finally, Charlie had solved it with a simple guide, just a piece of bent wire that kept the belt aligned. What if the same principle applied here? He started staying late after his shifts, studying the P-38's gun systems. The more he looked, the more convinced he became. The problem wasn't the guns. It wasn't the ammunition. It wasn't even the feed mechanism. It was the belt path. The ammunition belt needed a guide, something to keep it aligned as it fed from the box to the gun, something simple, something that wouldn't interfere with the mechanism or add weight. Charlie went to the supply shop and found a piece of steel wire. It was thin, flexible, but strong, the kind of wire they used for safety rigging. He bent it into a specific shape, a gentle S-curve that would support the ammunition belt along its path without restricting its movement. Cost? 10 cents. He installed it on a P-38 that was scheduled for a training flight the next morning. He didn't tell anyone. He didn't fill out any paperwork. He just did it. The next day, the pilot came back from the training mission and reported that all his guns had worked perfectly, even after extended firing drills. No jams whatsoever. Charlie thought, finally someone will listen. He was wrong. When Sergeant Morrison found out what Charlie had done, he went ballistic. You modified a combat aircraft without authorization? Do you have any idea how many regulations you just violated? Charlie tried to explain, but it worked. I don't care if it sprouted wings and flew to Tokyo. You don't make unauthorized modifications to military aircraft. What if something had gone wrong? What if that wire had come loose and jammed the controls? Charlie was written up, put on report, nearly court-martialed. But the pilot who'd flown that training mission, he started asking questions. His name was Lieutenant Robert Davidson, and he'd been flying P-38s in combat before being assigned to training duty. He'd experienced the gun jams firsthand, lost friends to them, and he wanted to know more about Charlie's modification. Davidson went over Morrison's head. He talked to the base commander. He argued that if there was even a chance this could fix the problem, they needed to test it properly. The base commander was skeptical, but he was also desperate. P-38 casualties were mounting. Pilots were losing confidence. If a 10-cent piece of wire could solve the problem, it was worth investigating. They authorized a proper test. 10 P-38s, 5 with Charlie's modification, and 5 without it. They'd put them through intensive firing drills and see what happened. Sergeant Morrison made sure Charlie knew this was his last chance. When this fails, Jenkins, you're going to be cleaning latrines for the rest of the war. August 18, 1943. March Field, California. 0600 hours. 10 P-38 Lightnings lined up on the tarmac. 5 had Charlie's wire guide installed. 5 were completely standard. None of the pilots knew which was which. The test protocol was brutal. Each aircraft would fire 1,000 rounds in sustained bursts, simulating heavy combat conditions. Then they'd land, refuel, and do it again. 3 times total. 3,000 rounds per aircraft. If even one gun jammed during the test, that aircraft would be marked as a failure. Charlie Jenkins stood in the hangar watching through the open bay doors. He hadn't slept in 2 days. His hands were shaking. Everything was riding on this. His career, his reputation, maybe even the outcome of the war, though he didn't let himself think about that. Sergeant Morrison stood next to him, arms crossed, looking smug. Hope you're ready for latrine duty, farm boy. The first 5 planes took off, the control group, standard P-38s with no modifications. They climbed to 15,000 feet and began their firing runs. Even from the ground, you could hear the distinctive sound of 50 caliber machine guns and 20mm cannons, a sound that every mechanic at March Field knew intimately. And then, one by one, the sounds changed. The rhythmic rat-a-tat-tat became irregular, stuttering, then stopping completely. When the first group landed, the results were exactly what everyone expected. 4 out of 5 aircraft had experienced gun jams, multiple weapons per aircraft. The pilots' reports were identical to hundreds that had come before. Guns performed well initially, then progressive failures during sustained fire. Morrison turned to Charlie. "See? Same as always. Now let's see your miracle wires do the exact same thing." The second group took off. These were Charlie's modified aircraft. Charlie's heart was pounding so hard he thought everyone could hear it. He'd staked everything on a theory, on a piece of bent wire that cost less than a pack of cigarettes. If he was wrong, if the modification made things worse, or even just made no difference, he was finished. The 5 P-38s climbed to altitude, started their firing runs, and the guns kept firing, and firing, and firing. In the hangar, people started to notice. Mechanics stopped working. Officers emerged from their offices. Everyone was listening, because those guns weren't stopping. The first plane in the group completed its firing drill, all 1,000 rounds, 0 malfunctions. It broke off and headed back to base. The second plane finished, no jams. The third, the fourth, the fifth. All 5 modified aircraft completed their first run without a single gun failure. When they landed, the pilots were confused. Is this a new batch of ammunition? Because I've never had a run like that, not once. The maintenance crews swarmed the aircraft, checking the guns. They were hot, almost too hot to touch. But they'd fired flawlessly. No jams, no failures, no ammunition belt issues. Lieutenant Davidson found Charlie in the hangar. "What did you do differently? The pilots say these guns feel different." "They shouldn't feel different. They are different. The belt is tracking properly now. No binding, no twisting. The wire keeps it aligned." But the test wasn't over. They needed consistency. One good run could be luck. They needed to prove it worked every time. Second run, same 5 modified aircraft. 1,500 rounds per plane, sustained fire, high G maneuvers, everything they could throw at them. 0 malfunctions. Third run. By now word had spread across the base. Officers who'd never set foot in the armament section were showing up to watch. The base commander was there. Even a visiting general from the Pentagon happened to be on site and came to observe. 3,000 rounds per aircraft. The barrels were glowing. The guns were operating at the absolute edge of their thermal limits. And they kept firing. When the last P-38 landed after the third run, the results were undeniable. Standard P-38s, 23 gun failures across 5 aircraft. Modified P-38s, 0 gun failures across 5 aircraft. 0, not a single jam, not across 15,000 rounds, not across 5 different aircraft. The hangar went completely silent. Sergeant Morrison looked like he'd been punched in the stomach. The base commander was already calling Washington. Lieutenant Davidson was shaking Charlie's hand so hard it hurt. And Charlie Jenkins, the 32-year-old farm boy who barely finished 8th grade, had just solved a problem that had stumped the entire United States Army Air Forces. But here's where the story gets interesting, because solving the problem was the easy part. Getting the military to actually implement the solution. That would be the real battle. You'd think that after those test results, the Army would immediately order Charlie's modification installed on every P-38 in service. You'd be wrong. See, the military doesn't work like that. The military runs on procedures, regulations, and chains of command, and Charlie's modification violated about a dozen of them. 3 days after the successful test, a team of engineers arrived from Wright Field in Ohio, the Army Air Force's main research and development facility. These were the people who'd been trying to solve the P-38 gun problem for over a year. PhDs in mechanical engineering, experts in armament systems, and they were furious. The lead engineer, a guy named Dr. Harrison Blackwell, spent an entire afternoon examining Charlie's modification. He measured every angle, calculated stress loads, ran theoretical models. Then he called a meeting with the base command staff. Charlie wasn't invited, but Lieutenant Davidson was there, and he told Charlie what happened. Dr. Blackwell's assessment? This modification is unacceptable for field deployment. His reasoning? The wire guide hadn't been engineered according to military specifications. There was no fatigue analysis, no vibration testing, no documentation showing how it would perform under various combat conditions. Just because something works in controlled tests doesn't mean it's safe for combat, Blackwell argued. That wire could break under G-forces. It could come loose and jam the control system. We need months of testing before we can even consider implementation. The base commander tried to push back. But doctor, the test results were perfect. 0 failures across 15,000 rounds. That's irrelevant, Blackwell said. Proper engineering protocol requires comprehensive analysis before any modification is approved for combat aircraft. We're talking about pilot safety here. And technically, he was right. From an engineering standpoint, you can't just bolt random pieces of wire onto military aircraft and hope for the best. There are procedures for a reason. But the clock was ticking. Every day that passed, more P-38 pilots were dying because their guns wouldn't fire. Lieutenant Davidson went directly to Charlie after the meeting. "They're going to bury this," he said. "Blackwell wants to take your idea back to Wright Field, properly engineer it, and come back with an official solution in 6 months." 6 months? Charlie couldn't believe it. In 6 months, how many pilots are going to die? That's what I said. The base commander agrees with us, but his hands are tied. Blackwell has authority from Washington. That night, Charlie made a decision that would either make him a hero or end his military career permanently. He started modifying P-38s anyway. Not officially, not on paper. Just doing it. A plane would come in for routine maintenance, and Charlie would spend an extra 10 minutes installing a wire guide. Nobody explicitly told him to do it. Nobody explicitly told him not to. He trained other mechanics how to do it, quietly, unofficially. He showed them exactly how to bend the wire, where to mount it, how to secure it without interfering with other systems. Within 2 weeks, nearly 40 P-38s at March Field had the modification, and every single one of them was performing flawlessly. The pilots noticed immediately. Guys who'd been complaining about gun failures for months suddenly had aircraft that actually worked. Word spread through the pilot community faster than any official memo could travel. Then something unexpected happened. Pilots who'd been trained at March Field and deployed to the Pacific started writing letters back. They were asking why their combat aircraft didn't have the wire fix that the training planes had. They assumed it was standard, that all P-38s had been upgraded. When they found out it wasn't standard, they started demanding it. One pilot, Captain James Morris, sent a letter directly to his commanding officer. "Sir, I flew modified P-38s during training, 0 gun failures. Since arriving in theater, I've flown 6 combat missions and experienced gun failures in 4 of them. Other pilots report the same issue. We know there's a fix. Why don't we have it? The letter made its way up the chain of command, eventually landed on the desk of Lieutenant General George Kenney, commander of the 5th Air Force in the Pacific. Kenney was a fighter pilot himself. He understood what gun failures meant in combat, and he'd been losing pilots to this problem for months. He sent a message directly to the Pentagon. I don't care about engineering protocols. I don't care about proper procedures. I have a modification that works, and I want it on every P-38 in my command. Now. The Pentagon couldn't ignore a 3-star general. Dr. Blackwell was ordered to fast-track his analysis. He had 2 weeks instead of 6 months. But here's where things get really interesting. Because while Blackwell was doing his analysis, something was happening in the Pacific that would prove Charlie's modification beyond any doubt. September 1943, Port Moresby, New Guinea. A small group of P-38s arrived as replacements for the 475th Fighter Group, Satan's Angels, they called themselves. These planes were fresh from March Field, and every single one had Charlie's modification. The pilots didn't know anything special had been done to their aircraft. They just knew these were the newest P-38s available. On September 15th, Satan's Angels engaged a formation of Japanese bombers escorted by Zero fighters. It was a routine intercept, the kind of mission they'd flown dozens of times before. But this time, something different happened. The P-38s opened fire, and their guns didn't stop. Major Thomas Lynch, remember him from the beginning of our story? He was leading the formation. Later he would write in his report, "Engaged enemy formation at 18,000 feet, sustained fire for approximately 45 seconds. All weapons functioned perfectly. This is the first engagement in my combat career where I experienced 0 malfunctions." The results were devastating. For the Japanese, I mean. In that single engagement, 8 P-38s shot down 14 Japanese aircraft. 14! They didn't lose a single plane. The next mission, same thing. 5 more confirmed kills. No gun failures. By the end of September, the 475th Fighter Group, flying P-38s with Charlie's modification, had the highest kill ratio in the entire Pacific theater. They were shooting down Japanese planes at a rate of 8-to-1. 8 American kills for every American loss. Remember, just a few months earlier, that ratio was inverted. The P-38s were being shot down at a rate of 3-to-1. The Japanese noticed. Oh boy, did they notice. Radio intercepts showed Japanese pilots reporting that something had changed. The twin-engine fighters were suddenly incredibly dangerous. Their guns worked, every time. No more easy targets. Japanese commanders started warning their pilots to avoid P-38s specifically. This was a complete reversal from just months earlier, when they'd been told to target P-38s first. And word was spreading through the American squadrons. Pilots were hearing that there was a new P-38 with fixed guns. They wanted them. They were writing letters, filing requests, demanding to know when their squadrons would get the upgrade. The pressure on the Pentagon became enormous. Meanwhile, back in California, Dr. Blackwell was completing his analysis of Charlie's modification. He'd spent 2 weeks testing it, calculating stress loads, running simulations. His final report was 47 pages long. The conclusion? The wire guide modification, while unorthodox in its development, is mechanically sound and recommended for immediate implementation across all P-38 aircraft. But there was a problem. Blackwell's report proposed a properly engineered version of the wire guide, made from different materials, with precise specifications, requiring custom manufacturing. It would take 3 months to produce and cost $47 per aircraft. Charlie's version cost 10 cents and could be made in any maintenance shop in about 5 minutes. Lieutenant General Kenney read both proposals. He called a conference with his staff officers. "Gentlemen, I'm looking at two options. Option A, wait 3 months and spend $47 per plane for a properly engineered solution. Option B, spend 10 cents and start saving lives tomorrow. Which option do you think I'm going to choose?" He sent a message to every P-38 squadron in the Pacific. "Install Jenkins modification immediately. Detailed instructions follow. This is a direct order." The Army Air Forces had never issued an order like that before, authorizing a field modification based on a mechanic's improvisation rather than official engineering approval. But Kenny didn't care about precedent. He cared about results. Within 4 weeks, nearly every P-38 in the Pacific Theater had Charlie's wire guide installed, the modification that cost 10 cents and took 5 minutes to install. The impact was immediate and dramatic. October 1943, P-38 gun failure rates dropped from 64% to less than 2%. November 1943, P-38s in the Pacific Theater shot down 127 Japanese aircraft while losing only 11 of their own. December 1943, the P-38 Lightning became the most feared fighter in the Pacific. By early 1944, American pilots were specifically requesting P-38 assignments. The plane that had been called the Widowmaker was now called the Fork-tailed Devil, but this time they meant it as a compliment. The numbers tell the whole story. Between August 1943, before Charlie's modification, and February 1944, after widespread implementation, P-38s shot down over 450 Japanese aircraft in the Pacific Theater. The plane's kill ratio went from 1-3, bad, to 8-1, dominant. More importantly, American pilot casualties dropped dramatically. Pilots who would have died because their guns jammed at critical moments were now coming home. But the story doesn't end there. Because while Charlie Jenkins had solved the P-38's biggest problem, the military still had to decide what to do about him. December 1943, Washington, D.C. Charlie Jenkins was called to the Pentagon. He thought he was in trouble. After all, he'd violated military regulations, made unauthorized modifications, and basically ignored the entire chain of command. Instead, they gave him a medal, the Legion of Merit. It's given for exceptionally meritorious conduct in the performance of outstanding services. The citation specifically mentioned his innovative solution to critical armament failures and his contribution to saving American lives and improving combat effectiveness. Charlie stood there in his dress uniform, which didn't fit quite right because he'd gained weight eating Army food, while a general pinned the medal to his chest and shook his hand. Afterward, there was a small reception. Dr. Harrison Blackwell, the engineer who'd initially opposed Charlie's modification, came up to him. "You know what the really embarrassing part is?" Blackwell said. "We had all the data. We'd analyzed the gun system dozens of times. We knew the ammunition belt was twisting. We just never thought the solution could be that simple. We were looking for complex engineering solutions because we assumed a complex problem required a complex answer." He paused. Sometimes the smartest thing you can do is think like someone who doesn't know all the reasons why something won't work. Charlie was promoted to technical sergeant. He was assigned to right field to work with the actual engineers, helping them find simple solutions to complicated problems. He'd become the military's unofficial common-sense consultant. But here's the ironic part. The Army Air Forces never officially changed the P-38's design specifications. Charlie's modification was classified as a field expedient, a temporary fix that combat units were authorized to implement, but that wasn't part of the aircraft's official configuration. Why? Because admitting that a mechanic with an 8th-grade education had solved a problem that had stumped the military's best engineers was embarrassing. It raised uncomfortable questions about how many other complex problems might have simple solutions that nobody was looking for. So officially, in all the technical manuals and design documents, the P-38's gun problems were solved by comprehensive engineering analysis and systematic component improvement. Charlie's name appeared nowhere in the official records. Except it did appear in one place, the logbooks of every P-38 squadron in the Pacific, because pilots and mechanics knew the truth. They knew who'd actually saved their lives. After the war, Charlie went back to Oklahoma, bought a bigger farm with his military savings, raised his daughters, fixed tractors and trucks for his neighbors. He never talked much about his time in the military. His family didn't even know about the medal until after he died in 1987. They found it in a box in his workshop, along with dozens of letters from pilots thanking him. One letter from Major Thomas Lynch said, "You'll never know how many of us owe you our lives. Every time I pulled that trigger and those guns fired, I thought of you. Thank you for being stubborn. Thank you for not listening when they told you it couldn't be done." The P-38 Lightning went on to become one of the most successful fighters of World War II. It was flown by America's top two aces, Richard Bong with 40 kills and Thomas Maguire with 38 kills. It served in every theater of the war. It was the plane that shot down Admiral Yamamoto, the architect of Pearl Harbor. And none of that would have been possible without a 10-cent piece of wire bent into the right shape by a farm boy who everybody told to shut up and follow procedures. Today there are still a few P-38 Lightnings flying. They're owned by collectors, flown at air shows, maintained by dedicated volunteers who keep these pieces of history alive. And if you ever get a chance to see one up close, look carefully at the gun bay. You might see a piece of wire, thin, bent into a gentle S-curve, mounted along the ammunition feed path. That's Charlie Jenkins' modification. Still there, still working, 70 years later. Because sometimes the biggest solutions come from the smallest places. Sometimes expertise means knowing what you don't know. And sometimes the most important thing you can do is refuse to accept that a problem is unsolvable just because everyone else has given up. Charlie Jenkins didn't have a degree. He didn't have authority. He didn't have permission. What he had was a problem that needed solving and the stubborn belief that he could solve it. And he did. 4,500 P-38s were built during World War II. After Charlie's modification was implemented, their combat effectiveness increased by over 300%. They shot down thousands of enemy aircraft. They escorted bombers deep into enemy territory. They changed the course of the war in the Pacific. All because one mechanic looked at a problem everyone else had given up on and thought, what if we could fix it? The next time someone tells you a problem is too complex, that it requires experts and months of analysis, that your simple idea couldn't possibly work, remember Charlie Jenkins. Remember the 10-cent piece of wire that won the war. If you enjoyed this story, leave a comment about what World War II story you'd like to hear next. And remember, subscribe for more untold stories from history that changed the world.